So in today's lecture, we will discuss about how to write the Verilog module for a BCD to 7 segment decoder using case statement. So in this lecture, first we shall discuss about the 7 segment display. Then we shall discuss about the Verilog module of BCD to 7 segment decoder using case statement. Then I will write the test bench for that Verilog module, and then I will show you the software demonstration. This is the 7 segment display which is available in the market. You can purchase this. So this 7 segment display comes in 10 pin package, right? So this is pin number 1, 2, 3, 4, 5, right? And 5 pins are that side. So in the last, this is 10th, 9, 8, and 2 more pins are there. So here you can find in this 7 segment display, there are 7 segments for displaying certain numbers, and these are the segments like this is called a segment A, B, C, D, E, F, and G. These are the 7 segments, and apart from these 7 segments, there is one segment for dot, right? This is also one segment. This is dot. Okay. So here you can see this 7 segment display with the pin numbers. Here pin number 1 is for segment E. Pin number 2 is for segment D. Pin number 4 is for segment C. Pin number 5 is for dot, right? This DP. Pin number 6 is for segment B. Pin number 7 for segment A. Pin number 9 for segment F, and pin number 10 for segment G. And pin number 3 and pin number 8. These pins are called as common pins, and internally they are connected with each other. You can use any one. Either you can use 3 or you can use pin number 8 as a common pin. Now in all these segments there is one LED. One LED is there in each segment, right? So this is the LED. Now to turn on this LED, there are two methods. One method is this. This end is called as cathode, and this end of the LED is called as anode, right? So to turn on this LED, anode should be kept at higher potential as compared to C. So if what we will do, if we will join this cathode terminal to ground, permanently we connect this to ground, and to the A terminal if we apply a plus 5 volt, right? If we apply a plus 5 volt, in binary we call it as binary 1, then this LED will turn on, right? It will glow. And if you apply a 0 volt, or in binary if we call it as binary 0, then anode and cathode both are at same potential, right? Because cathode is at ground, which is again 0 volt, and anode is also kept at 0 volt. So both are at the same potential. So LED will not turn on. It will turn off. So this is one method. And this type of approach, if LEDs of these all segments connected in this way, means their cathode is permanently connected to ground, then this type of 7 segment display is called as common cathode type 7 segment display, right? Means this LED which is for segment A, for B and for C, for all the segments, the common terminal is connected permanently to the ground through this common pin, right? Suppose this is your common cathode type of 7 segment display. So what we can do, this common pin we can connect to ground. By connecting it to ground, what we will achieve, we will connect all the cathode terminal of all these LEDs of all the segments will be permanently connected to ground. Now if you want to turn on this LED B, so at pin number 6 you have to apply binary 1. You apply binary 1, then the LED which is connected at segment B will be turned on, right? So this is one method, and the second method is like this. In this is the LED. Now in this LED, this is common terminal and this is this is cathode and this is anode. And now this anode is permanently connected to plus 5 volt, right? It is permanently connected to 5 volt. So in this case, to turn on this LED, what we have to do, to the cathode terminal, if we supply 0 volt, then this LED will turn on, right? Because cathode is at 0 volt, anode is at plus 5 volt, so LED will turn on. And if we connect the cathode terminal of this LED, if we apply a 5 volt, then cathode is at 5 volt, anode is at 5 volt. Both are at same potential, so there is no potential difference. So in this case, this LED is turned off. So if we purchase the LED from the market, and that is this type LED. So this type of LED is written, you can get in the market. Here it is written as CA. CA means common anode. Means all the LEDs of all these segments, the anode terminal are joined together and it is connected to this common pin. And this common pin, if you connect to plus 5 volt, then all the anode terminal of all the LEDs will be connected to plus 5 volt. And if you want to turn on this time this B LED which is connected at B segment, then in this case here at pin number 6 you have to apply binary 0. So now this LED will turn on, right? So there are two types of 7 segment which are available in the market. One is common cathode and one is common anode. In case of common cathode, this common terminal is connected to ground. It is connected to ground. In case of common anode type of 7 segment display, this common terminal is to be connected to plus 5 volt. So for this common terminal, you can use this pin number 3 or you can use this pin number 8. Any one pin you can use. Okay, so this is one example of common cathode 7 segment display. So it is like this. See this, for segment A, there is one LED. For segment B, there is another LED. For segment C, there is another LED. Like this, there are LEDs up to segment G, and there is one LED for your dot, this point. So now what will happen? This is the cathode terminal of the LED, this is the anode terminal of the LED, right? So all the LEDs, this is anode terminal and this is cathode terminal. Internally, all the cathode terminals are joined together and it is available at pin number 3 or pin number 8, right? You can see here this common pin number 3 and pin number 8. Now what you can do, now this is, since all the cathode terminals are connected, joined together to the common pin, so this LED is common cathode type LED. So what we have to do, we have to connect this to ground. We have to connect pin number 3 or pin number 8 to ground. Now here 5 is displayed, right? To display 5, what we need, we want to turn on the LEDs at segment A, segment C, segment D, segment F and segment G. So to turn on these segments, what we have to do at A, we have to send binary 1. At B, we have to send binary 0. At C, we have to send binary 1. At D, we have to send binary 1. At E, we have to send binary 0. At F, we have to send binary 1. And at G, we have to send binary 1. If you want to turn on dot, then you have to send 1, 1, or otherwise you can send 0. It does not matter. Okay. So in this way, if we send the binary values to in this sequence, then 5 will be displayed. So in this way, we can display various numbers. Now in this 7 segment display, we can display the numbers from 0 to 9, right? So numbers from 0 to 9 are called as BCD numbers, right? So BCD number means numbers from 0 to 9. So this is a BCD to 7 segment decoder. This is one hardware. In this hardware, if you enter the BCD numbers in binary form, then the 7 segments A to G, right here, the 7 segments, these 7 pins, pin number 0 to pin number 6, they will generate binary 0 or binary 1 to display the particular number as per the BCD inputs, right? For example, suppose if we want to display 0, then here we have to send BCD numbers, BCD input 0, 0, 0, 0, right? So how 0 will be displayed? 0 will be displayed in this way. In this way, right? Segment A, B, C, D, E, F. These segments should turn on. The LEDs of these segments should turn on. Now, since we are using here common cathode type 7 segment display, so this BCD to 7 segment decoder should generate the binary value so that A, B, C, D, E, F segment should turn on. So to turn on these segments, we know that in common cathode we have to generate binary 1, right? We have to generate the binary 1. So for example, A segment, A, this should get binary 1, B should get binary 1, C should get binary 1, D should get binary 1, E should get binary 1, F should get binary 1 and G should get binary 0. Okay. So see here to display, so these are the segments in this row, these are the segments, right? And A, B, C, D, E, F, G. So to display 0, at A we have to send 1, at B we have to send 1, at C we have to send 1, at D we have to send 1, at E we have to send 1, at F we have to send 1, at G we have to send 0, right? Same way we take another example. Suppose we want to display 2. How 2 will be displayed? 2 will be displayed in this way, right? So A segment, B segment, D segment, E segment and G segment. These segments should turn on. So see here, A segment is 1, B is 1, D is 1, E is 1 and G is 1 and other segments are 0. C is 0 and F is 0. So in this way, if at the input we send 0 here, So if we send the input BCD number like 0, 0, 1, 0, in this case the output should be like this, right? Output generated through this BCD segment decoder should be like this. So in this way we have written all the binary code for the display of numbers from 0 to 9. Okay, now we will write the Verilog code for this particular case by using case statement. So we start with the module and we end with the end module. The name given to this Verilog module is BCD, and the ports are BCD and SEG segment, right? So these are the inputs BCD, and this SEG is the output port. BCD is the input port. Of course, they are vectors, so we will declare these vectors in next step. Then next step, input 3:0 BCD. So this will create four vectors: BCD3, BCD2, BCD1, and BCD0. Then output 6:0 SEG. So it will generate 7 outputs, right? 7 outputs like this: S, E, G, 6, 2, S, E, G, 0. 7 vectors named as SEG0 to SEG6. Then we have declared rig 6:0 segment. So this segment is also declared as rig type. Okay. Now always at the rate BCD. So whatever are the other inputs, so these we are including in the sensitivity list of this always block. Then case BCD. So BCD is the expression depending upon the values of BCD. Any one arm of the case statement will be executed, right? So if the BCD input is, if the BCD is 0, this 0, 0, 0, 0, then to SEG segment we will assign these values: 0, 1, 1, 1, 1, 1, 1, right here. This 0, 1, 1, 1, 1, 1, 1, which is required to display 0. This. Okay. So here I have written comment also in 2 / display 0. Next, if the BCD input is 0, 0, 0, 1, then we have to assign 0, 0, 0, 0, 1, 1, 0 to SEG output. So if the input is 0, 0, 1, 0, then these set of value we have to display. So in this way, whatever these binary values we have written here, exactly in the same way we are assigning. For example, in this case 1, 0, 0, 1. If inputs BCD inputs are 1, 0, 0, 1, means we want to display 9. To display 9, we have to send this output, right, from the BCD to 7 segment decoder. And in the last default case, if nothing, these type of if BCD value is not in this range, then all the outputs will be 0. Nothing will be displayed. Okay. So this is the Verilog code. Now this is our unit under test, same BCD, the Verilog code which we have developed, and this is the test bench. Already we know that the ports of the test bench, which is connected to, which is interfaced with the input ports of the unit under test, will be declared as rig type. And the ports of the test bench, which is interfaced with the ports of the unit under test, will be declared as wire, right? So this is a test bench module, and module. Name of the test bench is test bench BCD. Read 3:0 BCD, wire 6:0 SEG, right? So this is the wire and this is the rig. So already we already discussed about how to do the instantiation and other things, and these are the values of the test bench on which we will test the conditions. Means if the inputs are 0 0 0 0, then what should be the output? If the input is 0 0 1 0 and if the input is 0 1 1 1, then what will be the output? So this is the test bench. Okay. Right, now I will show you this program. I will copy this code. Okay. So see here, this is the code of Verilog module of my BCD. So same, whatever just now I discussed, it is the same code here. Okay, and the test bench is this. This is the test bench. Whatever I discussed, same test bench is here. Now I will simulate this test bench. Okay, so first these are the output segment 6, segment 5, segment 4, segment 3, segment 2, segment 1, segment 0. Then BCD inputs BCD 3, BCD 2, BCD 1, BCD 0. So now you can see here, you can read this position, right? So this is okay. So BCD input is 0 0 0 0. So if this is the case, then what should be the output? So you can see this code. If BCD input is 0 0 0 0, this. If BCD input is 0 0 0 0, we have to display 0. And for displaying 0, the G segment should be 0. It should not glow, and remaining should be 1. So see here this code, this, right? G should be 0. And G, remember, G is connected to segment 6, right? So segment 6 is 0 and segment 0 to 5 should be 1. So we will check in this waveform. So you can check here, write this. Segment 6 is 0 and remaining segments are 1, 1, 1, 1, 1, 1. So these values are generated by BCD to 7 segment decoder, and if we connect these values to the 7 segment display, then 0 will be displayed. We check some other condition. Now you see the BCD input is 0 0 1 0. So what is the meaning of this 0 0 1 0? 0 0 1 0 means 2. We want to display 2. Now see here 0 0 1 0. This condition. 0 0 1 0. So we want to display 2, and how 2 will be displayed? For that, see here, 2 should be displayed in this way. Means C and F should be 0. So C is segment 2 and F is segment 5. Segment 2 and segment 5 should be 0. So check here. segment 5 is 0, segment 2 is 0, and remaining segments are 1. See, segment 0 is 1, segment 1 is 1, segment 3 is 1, segment 4 is 1, segment 6 is 1. Okay. Now we see some other condition. So here BCD input is 0 1 1 1. 0 1 1 1 means 7. We want to display 7. To display 7, what we need? This condition. To display 7, we want to send the value 0 0 0 0 1 1 1. Right? So segment 0, segment 1, segment 2. Here outputs. Segment 0, seg 0, seg 1 and seg 2 will be 1 and remaining should be 0. See here, segment 0, segment 1, segment 2 are 1 and remaining segments, segment 3, segment 4, segment 5, segment 6, they are 0. So in this way, this Verilog code is showing us the functionality of BCD to 7 segment decoder.